In this video, we're going to cover the sum and difference identities. I'll walk you through the formulas, but I won't prove any. We will go through applications, however. These formulas might seem long, but are not too bad to remember. So, sine of A plus or minus B will be sine of A cosine of B plus or minus sine B cosine A. So if we have a plus inside here, then we'll have a plus out here. If we have a minus, then we'll follow the minus sign. So for cosine of A plus or minus B, that'll be cosine A, cosine B, minus plus sine A, sine B. So if we have a plus here, we'll actually go with a minus. If we have a minus in here, then we'll go with the plus. Now for tangent of A plus or minus B, that'll be tangent A plus minus tangent B over 1 minus plus tangent A tangent B. All right, so let's try something like sine of 15 degrees out. Now, the trick is to actually rewrite 15 degrees as a sum or difference of 30 degrees, 45 degrees, or 60 degrees, because these are the angles we're most familiar with. Now, as it turns out, we can rewrite 15 degrees as 45 minus 30. So we'll do that instead. So sine of 15 degrees is equal to sine of 45 degrees minus 30 degrees. And now we just have to follow our formula. So that'll be sine of 45 degrees, cosine of 30 degrees, then minus sine of 30 degrees, cosine of 45 degrees. Now we just have to evaluate each expression here. So sine of 45 degrees is root 2 over 2, and then cosine of 30 degrees is root 3 over 2. Minus sine of 30 is 1/2, cosine of 45 is root 2 over 2. Now we just have to simplify. Let's start with our first expression. So root 2 times root 3 is root 6 over 2 times 2, which is 4. 1 times root 2 is just root 2 over 2 times 2, which is 4. Now they have a common denominator, so we'll join it as one fraction. And we'll have root 6 minus root 2 all over 4. And that's our answer. Now, with cosine of 105 degrees, you might try to use a reference angle. But we'll find that our reference angle will actually be 75 degrees. And that's not immediately obvious to us. So let's try use sum difference. So can we rewrite 105 as a sum or difference of 30 degrees, 60 degrees, and 45 degrees? Well, as it turns out, we can actually, because 60 plus 45 is equal to 105. So we'll use this sum instead. So cosine of 105 degrees is the same as cosine of 60 degrees plus 45 degrees. So we'll just have to follow our formula. So that's cosine of 60 degrees times cosine of 45 degrees. So plus there, so minus here. Sine of 60 degrees and sine of 45 degrees. And now just to evaluate. Cosine of 60 is 1/2. Cosine of 45 degrees is root 2 over 2. Minus sine of 60 is root 3 over 2, and then sine of 45 is root 2 over 2. And now just simplify here. First term, 1 times root 2 is root 2, over 2 times 2 is 4, and that'll turn to root 6 over 4, and under one fraction here, root 2 minus root 6 all over 4. And that's our answer here. So let's try something like tangent of 15 degrees. Now we actually already know that 15 can be rewritten as 45 minus 30. So let's go on with that. So tangent of 45 minus 30 So that'll be tangent of 45 minus tangent of 30 over 1 plus tangent of 45 and tangent of 30. So we'll evaluate here. So tangent of 45 is 1 minus tangent of 30, which is root 3 over 3. We have the 1 plus tangent of 45 is 1. Tangent of 30 is root 3 over 3. So now we have this expression here. 1 minus root 3 over 1 plus root 3 over 3. So we could definitely simplify this. We'll start by multiplying by 3 on the numerator and the denominator to get rid of the fraction, which will give us 3 minus root 3 once we distribute, and 3 plus root 3. Now we do have to rationalize our denominator, and to do that, we'll just multiply by the conjugate of our denominator, which will be 3 minus root 3. And then 3 minus root 3 in the numerator as well. So we just have to FOIL our numerator. So that'll be 9. And then we'll have a minus 3 root 3. The outer. Inner will be minus 3 root 3. And then last, negative root 3 times negative root 3 is positive 3. And our denominator is a difference of 2 squares. So it will just be the difference of the square of both terms. So 9 minus and square root of 3 squared, which is just 3. Now to combine like terms, we have a 9 and we have a 3, so we can add that to 12. Negative 3 root 3 minus 3 root 3 would be negative 6 root 3. And our denominator is 9 minus 3, which is just 6. And we can split this up to 12 over 6 minus 6 root 3 over 6. 12 over 6 is 2. We can see the 6's cancel out here. And we're just left with the root 3. So our final answer is 2 minus root 3. Now we're going to go the other direction here. So looking at the expression itself, things like sine of 48, cosine of 12, I don't know the exact answer. I'm very unaware. But it does follow the format of our sum and difference identities. In fact, this actually looks like the sine sum and difference identity. And since we have a plus here, if we look at our formula, if we have a plus on the outside, we'll actually have a plus on the inside. And our two angles we're adding will actually be 48 and 12. So that's equal to sine of 48 degrees plus 12 degrees. Again, you can pull out the formula and just verify that this expression here on the right-hand side is equal to the expression on the left-hand side. So instead of evaluating the left-hand side, we'll just evaluate the right-hand side. Sine of 48 degrees plus 12 degrees. And that's just sine of 60 degrees. And we know that to be root 3 over 2. So same idea here with tangent. Each expression on its own, like tangent is 20 degrees, tangent of 10 degrees. Don't know, not any of the familiar angles, but it just so happens to follow the format of the tangent sum or difference identity here. So if we have a plus here, that means we're going to add these two angles here. So that'll be 20 plus 10 degrees. And we can actually just do that instead. Tangent of 20 degrees plus 10 degrees is tangent of 30 degrees. And tangent of 30 degrees is just root 3 over 3.